Assalamu alaikum everyone, this is Fahad Ansari and I'm here to help you conquer chemistry. In this video we will start a new chapter on chemical bonding. So before we begin on the formal definition of bonding, you may have seen stuff like this. This is called a ball and stick model, right? And normally what you do is you join together atoms of different elements and you link them together using these sticks, right? So for example, this over here is a molecule of water. This is the ball and stick model for water. You have one oxygen atom that is bonded to two hydrogen atoms. And these sticks over here that are in between the oxygen atom and each hydrogen atom, this is called a bond. Now, the thing about bonding is the reason why atoms of different elements, they form bonds with atoms either of the same element or of different elements is to gain a complete outer shell, right? So that's the entire purpose of bonding. Now this purpose of bonding to get a complete outer shell or valence shell of electrons can be fulfilled in two ways. Either by transferring electrons from one atom to the next or by sharing electrons, right? So that gives rise to two types of bonding, and we will discuss this first type of bonding by the transfer of electrons in this video. So the first example that I'm going to look at by discussing bonding by the transfer of electrons, this is actually called ionic bonding, right? And how does this come into effect? We will see with the example of sodium chloride, which you guys already know as table salt, or as I like to call it, salt-base weapon of choice. So sodium chloride over here basically features two atoms, right? So you have a sodium atom over here. Now this is a metal, right? Sodium is a metal, and sodium has a proton number of 11. So that means its electronic configuration is 2, 8, 1, right? In case you don't know what electronic configuration is, you should watch my previous videos to get an idea. So this metal atom over here has just one electron in its outer shell. Now to get a full outer shell of electrons, it can do two things, right? The first thing, which is obviously the harder option, is to gain 7 electrons to get a complete outer shell. Because remember, a complete outer shell means 8 electrons in it, right? Now gaining 7 electrons is a very long process, very tiring, lots of energy required. So the easier process would be to just lose 1 electron. So this 1 electron in the third shell can be lost. And so this second shell over here, which is already complete, will become the outer shell, which already has 8 electrons in it, right? So over here, I'm going to just show the outer shell of sodium atom with just this 1 electron in it, right? Before I show the transfer of electrons, let's take a look at the chlorine atom over here. Now this over here is a nonmetal. This is a nonmetal atom. And the proton number of chlorine is 17. So its electronic configuration would be 2, 8, 7, right? Now, again, two options for this guy over here. Either it could lose 7 electrons so that the second shell, which is already complete, becomes the outer shell, or it could just gain 1 electron and the 7 over here becomes 8, right? So if it gains 1 electron, this outer shell or valence shell will become complete. So I'm going to represent its 7 valence electrons using crosses. I used a dot to represent the one and only valence electron of sodium and crosses for the 7 valence electrons in the atom of chlorine. Right. Now I'm going to show the transfer of electron from sodium to chlorine so that both of them get complete outer shells through this exercise of bonding, right? Now I'm going to show this dot over here that tells me that the chlorine gained the electron and this was an electron that sodium lost, right? Now this shows the transfer of electrons But now if I were to show the outer shells of the ions, I'm going to erase this. And you're going to see that chlorine has a full outer shell of 8 electrons, 7 that it already had and the 1 that it gained. And sodium, its third shell, is empty, right? So I could either show it as an empty outer shell, or I could draw in 8 dots to show the 8 electrons in the second shell, which now becomes the ion's outer shell, right? So I'm just going to leave it empty because it's the third shell that became empty by losing 1 electron. Now, the sodium atom, we know that atoms are electrically neutral. They have an equal number of protons and electrons, right? So the atom had 11 protons and 11 electrons. Now, because it has lost 1 electron, that's what it went with, so now we have 10 electrons. So the total charge on this thing is going to be plus 11 from the 11 protons, and then you add to it the minus 10 from the 10 electrons. That gives you a plus 1 charge. So the sodium ion, this word ion that I've been bandying about so far, just means a charged particle, right? That is formed from an atom by the gain or loss of electrons. In this case, the sodium atom lost 1 electron, so it gained 1 positive charge that I've written here outside the square brackets at the top right corner. For chlorine, on the other hand, because it has gained 1 electron, I'll use square brackets again to show that the charge on this ion is spread out throughout the ion, right? Now this forms a negatively charged ion because the atom had 17 protons and 17 electrons, right? Now because it has gained 1 electron, so it now has a total of 18 electrons. And so when you add up the charges, plus 17 from the 17 protons, plus minus 18 from the 18 electrons, that gives you minus 1. So this is 1 negative charge. And in between them, you're going to have a force of attraction between this positively charged sodium ion and this negatively charged chloride ion. Call this chloride. We changed the name from chlorine to chloride. This force of attraction is known as the ionic bond between oppositely charged ions. Positive ions from the metal atom and negative ions formed from the non-metal atom. So in summary, we have a metal and a non-metal atom that are involved. In this case, the metal was sodium and the non-metal was chlorine. Metal atoms, they lose electrons, right? And they form positively charged ions, or positive ions, also known as cations. In this case, the cation was the sodium ion with 1 plus charge. The non-metal atom, it gains electrons to form a negative ion, also known as the anion, right? So over here, the chlorine atom, the non-metal atom, it gained 1 electron to form a Cl negative ion with 1 negative charge. So the force of attraction between the oppositely charged ions which attract is called the electrostatic force of attraction. We call this electrostatic because these charges are not going anywhere, they are stationary, right? And this electrostatic force of attraction is called an ionic bond. Let's look at another example. So I'm going to quickly run through this. So we have magnesium over here, proton number 12, right? Electronic configuration of 2, 8, 2. So for this, it could either gain 6 electrons or lose 2 electrons to form a complete outer shell. So obviously I'm going to go with losing 2 electrons, right? So I'm going to show these with dots, right? 2 dots for 2 valence electrons in the atom, right? And for fluorine, the proton number is 9, right? So 2, 7 is the electronic configuration. And we already have 7 electrons in the valence shell. Just needs to gain 1 more to complete the outer shell with 8 electrons. So I'm going to draw crosses for the 7 valence electrons for fluorine. And same case goes over here. Now the thing is that each fluorine atom needs only 1 more electron to complete its outer shell. Magnesium, though, needs to lose 2 electrons to make the second shell its complete outer shell, which already has 8 electrons. So what happens is that the magnesium will transfer 1 electron to one fluorine atom over here, and it will transfer the second electron to the second fluorine atom over here. And so the outer shells of both the magnesium and fluoride ions, we've changed the name from fluorine to fluoride. We take the first syllable of the nonmetal's name, fluorine, we take fluor and then add ide to the end. That makes the name of the nonmetal ion. So let's just erase these arrows. These electrons are already gone. And we're going to draw these square brackets to show that the charges on these charged particles or ions that are formed from the gain of electrons, in this case, for fluoride, 1 electron is gained, so 1 negative charge. And same case for this fellow over here. And for this magnesium atom, because it lost 2 electrons, so it has a 2 positive charge. So we have ionic bonds between this negative ion and this positive ion, and between the positive ion in the center and this negative ion, right? So the fluoride ions are your anions, the magnesium ion is your cation, right? So this is your anion, all right? This is your cation, and this is your anion, right? Now, some students get confused, especially when they're learning this for the first time, the difference between an anion and a cation, right? So remember, cations are positive ions, right? The way I remembered this when I was a student was that the positive ion is the cation, right? The word cat, and cats make me happy, they make me feel positive, so the cation is the positive ion, right? Anion, on the other hand, looks very close to onion, right? And when you chop onions, they make you cry, they make you feel negative. So, anion it is. I know that's a lame example, but you do anything to remember these things, right? Anyway, so properties of ionic compounds, let's quickly run through this. So, structure is giant ionic lattice. So what does that mean? That means that giant basically means many millions of ions, right? And lattice means a regular pattern, right? So this is a regular pattern. And what is this regular pattern? Of alternating negative and positive ions, right? So you have negative followed by positive followed by negative. And this goes in all directions, right? So we have negative followed by positive followed by negative, negative, positive, negative, alternating positive and negative ions or cations and anions, right? A giant basically means that this goes on forever, right? So properties of ionic compounds, the first property is that high melting points, right? The reason is that you have charged particles called ions that are attracted to each other, and in between them you have electrostatic forces of attraction. These are very strong and these are difficult to break. And because these are difficult to break, you need a lot of energy to break these electrostatic forces of attraction so that these ions that are rigidly held in the lattice in the solid state can be broken up and become free to move in the liquid state. So next property is that they're good conductors of electricity when molten or in aqueous solution. Now the reason for that is that in the molten state or in the aqueous solution, the ions are free to move. In the solid state, the ions are in fixed positions, just like in most solids, but in molten or aqueous state, ions are free to move. So if you apply a potential difference across a molten or aqueous solution of an ionic compound, the ions can carry the charge from one end to the other and so conduct electricity. These ions that are free to move, we call them mobile ions. The third property is that they're soluble in water. Now, I'm not going to go into the details of why that's the case. That's for a future video. But just need to remember that salts and other ionic compounds in general, such as sodium chloride, are generally soluble in water. All right, so that's enough about ionic compounds. So I hope you enjoyed this video. If you did, leave a like, do subscribe to the channel, share this video, and inshallah, I will see you in the next video.